What do you call a robot that can walk, crawl, and even run? A transformer? No, it's Boston Dynamics' new Atlas. With a team focused on pushing humanoid robotics to their limit, the new generation of Atlas is more agile and much better at imitating humans than ever before. With billions of dollars going to produce state-of-the-art hardware and mechanics that rival our best athletes, it's understandable that Atlas is creeping some people out, and they might be onto something. But that begs the question, are we making our lives easier, or simply building physically superior replacements? If you've seen my earlier video on AI robots, you've seen me cover Boston Dynamics' impressive Atlas bot for its superior mobility and athleticism. However, way before their latest model could perform parkour, the first generation of Atlas robots were clunky inventions that needed an external power source and struggled with basic movements. In fact, Boston Dynamics' focus in the 80s and 90s when they first launched were mostly quadruped robots with clunky frames that ran, hopped, and jumped. However, the team received some mainstream fame and recognition in the early 2000s with inventions like the Cheetah and Spot Mini that went viral. At record speeds of 28.3 miles per hour, the Cheetah robot easily became Boston Dynamics' fastest running quadruped, making it 0.5 miles per hour faster than Usain Bolt's fastest 20-meter sprint. Although this feat was in no small part thanks to the funding the company received from the U.S. Defense Advanced Research Projects Agency, DARPA. The government agency also funded the invention of the Spot Mini, a smaller version of the Spot Dog capable of running for 90 minutes without charge. At a mere 65 pounds, it was the smallest four-legged robot in 2018 when it made its debut. Even with its small frame, packed with multiple depth cameras, a solid-state gyro, and proprioceptive sensors, it was capable of performing tasks like walking autonomously, making it one of the most advanced quadruped bots for its time. Despite these wins with their quadruped model, Boston Dynamic had a harder time translating their success to their bipedal models. When Atlas's first prototype launched in 2013, DARPA program manager Gil Pratt described it as a one-year-old child that can barely walk. You see, the first Atlas model was nothing like the sleek modern one that can do parkour today. Standing at 6 foot tall and weighing 330 pounds, it was less human and more machine in appearance with its exposed wiring and hydraulics system. Its heavy metallic frame also held a boxy torso, with basic sensors to control its oversized feet when walking. When Boston Dynamic revealed their new bipedal bot, the New York Times called it a giant, though shaky, step toward the long-anticipated age of humanoid robots. Over the years, Boston Dynamic would become significantly better at refining their robots' mobility and dexterity, and their improvements would shine through in every new model. For example, in 2016, they launched their first fully untethered bipedal robot, capable of walking on rough terrain like snow. The team also improved the LiDAR stereo sensors in the bot's body and legs, giving it the ability to stand up on its feet like a jack-in-the-box after being pushed over. Then in 2017, they stepped up the bot's agility and released an updated video showing it jumping over boxes, turning 180 degrees, and even performing a backflip. By 2020, it could perform a dance routine in sync with another Atlas robot. And in the next year, it grew even more impressive, finally being able to run through a parkour course complete with jumps, beams, and vaults with enough fluidity to make Michael Scott jealous. With each model, Atlas also got sleeker and more modern, reaching the peak of its humanoid appearance and compatibility when Boston Dynamics switched from a hydraulic design to an electric one in 2024. Now, the latest Atlas generation is a lot leaner and sleeker since it shed its bulky hydraulic system. Besides being more compact, the new electric system means Atlas is a lot quieter, making for a more enjoyable experience for the humans that have to work side by side with it. An electric model also makes this humanoid more energy efficient, consuming far less power to execute more precise movements. It also has a wider range of motion, in no small part thanks to its new lightweight build that's much better at mimicking human-like flexibility while being more durable. However, one of the most impressive upgrades of this new model is how natural its movements are compared to previous models. With more advanced computer vision and better deep learning algorithms, it can adapt to its surroundings in real time, making its movements more seamless. In one of Boston Dynamics' latest videos, they captured their new Atlas showcasing human-like motions such as leaning forward when running and tucking its torso in when it slows down. These movements are so eerily human. It's both fascinating and eerie to watch how it smoothly got down on its hands and one knee before breakdancing. It could also crawl on all fours and perform a handstand, all with the human-like grace of a professional athlete. Another fascinating addition to Atlas's electric models is their 360-degree swiveling capability at the hips, waist, arm, and neck. Not only do these upgrades make it more flexible than the average human, they make its moves much cooler to witness. For example, in the full video, you can see the Atlas freely swiveling its hips to turn a handstand into a round-off right before it stands up with its head backwards. The company attributes these eerily human-like movements to a combination of athletic intelligence and model predictive control. That means Atlas learns from watching other models and humans perform movement, allowing it to accurately predict and adjust its motion. As a result, by connecting this advanced AI perception with control, Atlas can adapt to new terrain or moving objects while on the go. Of course, its depth sensors also play a huge role in ensuring Atlas sees and reacts to its surroundings in real time. To pull off all its athletic moves with greater precision, the humanoid uses a complex, high-performance computing platform called the Jetson Thor. Of course, this should come as no surprise to you if you heard about the collaboration Boston Dynamics announced with the best in the game, NVIDIA Corp. Despite recent news about the company's stocks losing value, NVIDIA remains one of the world's leading computer manufacturing corporations, producing the necessary hardware to make bots like Atlas jump, crawl, and run. As a result, Boston Dynamics is one of the first in line to use NVIDIA's Isaac GR00T to enhance their robots' capabilities. As part of that framework, the Jetson Thor comes in a compact size that integrates seamlessly with Atlas's whole body and manipulation controllers. According to the company's chief technology officer, Aaron Saunders, collaborating with NVIDIA to integrate Jetson Thor means that robot now has the highest performance computing platform behind it. Isaac Lab is allowing us to develop state-of-the-art AI capabilities, and the early results are exciting. If you don't know, Isaac Lab is a unified and modular framework that AI robots can use for reinforcement learning or motion planning. In other words, it's kind of like a virtual reality video game for robots, complete with photorealistic scenes and fast simulations that help the bot figure out how to perform tasks in the real world. Think of it like a driving simulator before you enter a real car. The benefit of Isaac's Lab is that it's easily customizable, making it cheaper and far more efficient to train robots to do things like laundry, cleaning, or even moving objects. It's also open source, so you can train your robot with the likes of Boston Dynamics' Spot and Unitree G1 to perform dexterous movements. I imagine it was through multiple simulations in Isaac's lab, Unitree Robotics was able to get their G1 humanoid to perform a groundbreaking side flip, showing that Boston Dynamics' partnership with NVIDIA is vital to helping their AI-powered bots achieve amazing feats of flexibility and agility. Of course, all of this is built on the back of NVIDIA's Isaac Sim, which is what allows developers to build an extensive universal scene description, OpenUSD. In other words, it is the backbone of the Isaac Labs simulator, allowing developers to simulate and test AI-driven robotic solutions. But how exactly does this work? For example, let's say you're trying to train a robot to pick up a box. The Isaac Sim is responsible for creating the hyper-realistic virtual environment by generating synthetic data of the object in different positions, textures, and lighting conditions. This process happens inside the Isaac Lab, which provides the tools and instructions for the robot to execute the task. Together, they create a training loop with reinforcement learning to ensure the AI can perform the task in the real world. After receiving such training, bots like Boston Dynamics Atlas and the Unitree G1 are capable of performing backflips and side flips with flawless, human-like grace. Beyond participating in the Robot Olympics, Atlas is primarily meant to assist in search and rescue missions, where it can move across different terrains, help with navigation, and even manipulate objects. That's why DARPA is pouring millions of dollars into improving the humanoid AI's strength, endurance, and precision in various areas. When the US government is ready to launch it, the final model should be able to carry supplies and aid first responders in disaster zones. Imagine how useful several bots like these would be in evacuating people during times of crisis, such as during the California fires or when Hurricane Milton hit Florida late last year. Besides saving lives, Atlas can also reduce workload and prevent injuries in the workplace by taking on dull, repetitive, and dangerous jobs. Boston Dynamics showcased that the humanoid robot is set to work in Hyundai facilities, helping to pick up, carry, and place objects on their assembly line, thus automating the sequencing process in their automotive manufacturing. Since Boston Dynamics released the first Atlas generation, for the most part, it has struggled with recreating fluid human-like motion, and only really started accomplishing such feats in recent years. As impressive as it is to watch a machine travel across rubble, jump over obstacles, and perform tasks typically reserved for humans, it does raise multiple concerns. For example, when Boston Dynamics went fully electric in 2024, they released a video of the bot lying face down on the floor before swiftly folding its legs backwards and rising to its feet before swiveling its face and waist 180 degrees and marching forward. Clearly, the intent of the video was to show off the robot's impressive degree of freedom and mobility, even surpassing that of the average human. However, responses were mixed. In an article from The Verge titled "Boston Dynamics' New Atlas Robot is a Swiveling, Shape-Shifting Nightmare," Jess Weatherbed called it unnerving and compared the motion to a Cronenberg body horror flick. Reactions in the video's comment section ranged from comical, with one user saying, "This is the final evolution of the Pixar lamp," to others agreeing with Weatherbed by calling it nightmare-inducing. Sentiments were mostly similar in one of their latest videos, released on March 19, 2025, showing how the latest Atlas robot can walk, run, and crawl using reinforcement learning captured from watching human motion and animation. Several viewers made jokes about how the humanoid's advancements in agility signaled end times, with one person joking, "It's been nice watching the origin story of our apocalypse these past 20 years. Progress." And another saying, "It was nice knowing all of you guys. We had a good run." On the other hand, responses weren't all negative, as some users simply acknowledged the company's progress, with one person commending Boston Dynamics by saying, "That is by far the most fluid and smooth I have seen a humanoid robot walk and run. Bravo, guys." Another also said, "The movements have gotten so natural, it's easy to forget the amount of work needed to figure all of that out." So how do you feel about Boston Dynamics' new electric model? Do you envision a future where humans and their physically superior humanoid assistants live in peace side by side? Or are we truly witnessing the beginning of Skynet in real time? If so, Boston Dynamics won't be the only bot we have to worry about in a war between people and machines. With a biomimetic design, Clone Alpha's musculoskeletal and vascular structure mimics human anatomy to a startling degree. Clone Robotics has also begun accepting pre-orders, so there's a possibility they might hit the mainstream market at the same time as Tesla's equally impressive humanoid Optimus. In 2024, the company's CEO, Elon Musk, announced on his Twitter page that Tesla will have genuinely useful humanoid robots in low production for Tesla internal use next year and, hopefully, high production for other companies in 2026. That means it's reasonable to assume that before the year 2030, we can expect these humanoid bots to become a noticeable part of the workforce in high-tech and forward-thinking companies. Other companies that are also making impressive strides with their humanoid robots include Apptronik. Currently, they're collaborating with the automobile company Mercedes-Benz to test their Apollo robots in their manufacturing line. According to Apptronik's CEO, Jeff Cardenas, the big idea is a humanoid robot should be able to fit in all the places that a human can fit into and use all the same tools that humans can use. His thought process is that building such a world will prevent the need to modify our world for robots. However, that begs the question. If robots can easily fit in human spaces, what happens to the humans that are shoved out? Besides, with other automobile companies like BMW also using humanoid AI, Figure 02, in their plants, we're going to have to answer that question sooner rather than later. What's more, they may even be able to reproduce without our input, as manufacturing facilities are now building robots that can build other robots. If you're interested in autonomous robot replication, check out my other video on robots giving birth. Who knows, in some distant future, humanoid robots may even outnumber us. So what are your thoughts on Boston Dynamics' new Atlas? Is it a next-generation tool that marks the beginning of humanoid robots overtaking and replacing real humans? And what do its achievements mean for the future of work? Let me know in the comments section below. And thank you for making it till the end. If you don't want to miss out on the latest AI updates, be sure to hit the like button and subscribe.